Welcome all. Now I am going to discuss question number 12 from the GATE 2019 paper Electrical Engineering. The question is, in the circuit shown below, the switch is closed at t is equal to 0. The value of theta in degrees, which will give the maximum value of DC offset of the current at the time of switching is. These are the given options. To know the detailed analysis of first order RL circuits, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. This is the circuit given RL circuit and it is closed at t is equal to 0 with a supply voltage of some magnitude and phase angle. So, to analyze the circuit, we need to do a mesh analysis to solve the problem. That is equal to V of t. Supply voltage is equal to resistance drop plus reactance drop. That is I of t into R plus L into d I of t by dt. So, the solution to this particular equation is the complementary integral plus particular integral. Here, complementary integral denotes the transient part and the particular integral denotes the steady state part. And it is given by I of t is equal to a into e to the power of minus r by L into t plus Vm by Z sin omega t plus theta minus phi, where phi as the tan inverse of omega L by r. Here, as we have already said that complementary integral denotes the transient part that gives the DC offset. So, to find the maximum value of theta, we need to find out analyze this equation at t equal to 0. So, by using this information, let us solve the problem. So, first given data. Given it is switch is closed at t is equal to 0. T is equal to 0. Switch is closed. So, and we need to find out the value of theta at which the maximum value of DC offset. Maximum value of DC offset. And we know that current drawn by the circuit I of t is equal to a into e to the power of minus r by L into t plus Vm by Z into sin omega t plus theta minus phi. So, phi is the tan inverse of omega L by R. So, we need to find out the maximum value of the DC offset at t is equal to 0. So, let us analyze at t is equal to 0. Inductor does not allow sudden changes in the current rate. So, I of t is equal to 0. Since inductor does not allow sudden changes in the current. Sudden changes in the current. So, I of t is 0. So, 0 is equal to a into e to the power of 0 plus Vm by Z into sin theta minus phi. So, A is equal to minus Vm by Z sin theta minus phi. Theta minus phi, right? And maximum DC offset when it will come theta minus phi is equal to 90 degrees. Since if sin theta minus phi is equal to minus 1 means A is equal to, anyway Vm is constant, Z is constant. So A gives the maximum value, positive value, DC offset. So when this will be equal to minus 1, theta minus phi is equal to minus 90 degrees. And we know that phi is tan inverse of omega L by R. Omega L by R is equal to minus 90 degrees. Omega is 377. In the question, it is given that omega as 377, right? So we will substitute 377 into L value is how much? L value is 10 millihenry. 10 into 10 to the power of minus 3 divided by R is 3.77 ohms. So tan inverse of theta minus tan inverse of omega L by R is equal to minus 90 degrees. So theta minus tan inverse of 3.77 divided by 3.771 is equal to minus 90 degrees. Implies theta is equal to tan inverse of 1 is 45, right? So theta is equal to 45 degrees, minus 45 degrees. So at this value of theta, the circuit will give maximum value of the DC offset current. So the maximum value of the DC offset current at the time of switching is minus 45 degrees. Thank you.